Okay, so let's talk about the distance. So when you've done the distance formula before on the XY axis. If you don't know what the distance formula is, because I would think at least some of you wouldn't be able to rattle it off at this point. Remember, it's that big old yucky square root thing. But what could you use instead of that? Like you want the distance between 2 points on a coordinate plane that you already know how to do. The distance formula, you don't have a formula chart, you don't know what it is. How can you find the distance between those 2 points? Pythagorean theorem, right? Because isn't that where the distance formula comes from? Comes from the Pythagorean theorem. So if all else fails, you can do the Pythagorean theorem, right? So let me remind you about the distance formula, which I know for sure you do in geometry. You might have learned it in Algebra 1. Also, sometimes it's an Algebra 1 thing, sometimes it's not. But so here are your 2 points on the coordinate plane, right? So if I want the distance, see, this is when we came up with the distance formula. Use Pythagorean theorem. These are the actual distances when you don't have numbers in there. And then you end up with this, right? But if you don't know what that is, if you can just connect these 2 points and, put your little dotted lines, find these links, you can do Pythagorean theorem, right? And that's important to know in case you don't remember what this is. Well, on the polar coordinate system, you don't get to use the Pythagorean theorem. That doesn't work. But it is tied to the law of cosines. So find the law of cosines. I believe it's on page 99 in your ISN. Find that. And then underneath this circle, leave yourself some space, but then we're going to write the law of cosines like right here. All right, so there's 3 different forms of it, right? And they're pretty much all the same. It just, because those letters aren't usually what's in your triangles anyway. But who wants to give me one of the versions? Anybody? Somebody? Anybody? Oh, cosine of A. Oh, goodness. Let me write this where you can read it. All right. And at the top of those notes is kind of where it comes from. That was a little bit more, it just works out from, that comes from something else, and then we use that here and go on and on. So here, if I have this triangle, right? So find missing sides of triangles that aren't right triangles. Hopefully that doesn't look like a right triangle. So if I'm looking for A, this length would be A. That means this would be angle A, which we called angle A here, but it's also the angle that we have. We'll call it theta. And then we're going to have B and C. So if this is little b and this is little c, that means this is capital B and this is capital C, right? So in order to find A, this length here, we would have to know 2 side lengths and the included angle, right? That's in a nutshell what the law of cosines is. It allows you to find that missing side when it's not a right triangle if you know the side angle side part of it, okay? So let's look at how that works here. So you have these 2 points that are plotted on your polar axis. This, and it's teeny tiny, this is P1, right? I had trouble even seeing it on the notes. Yeah. I'm going to write this bigger because I can't see it. P1, and this is P2. Okay, so there are 2 points. And we would know these ordered pairs, just like you would know X and Y for both ordered pairs if you're using the distance formula on the rectangular coordinate plane. So I know these 2. I'm not making a right triangle out of this like we would on the rectangular coordinate plane because we're not dealing with that. But I would take these 2 points, and if we connect them to the pole like this, we get a triangle. It's possible you end up with the right triangle. That's definitely possible at some point, but it's not a guarantee. So we want to make sure it works for all of them. I would be looking for the distance between these 2 points. That would be the D I'm looking for right there. The length of this is the radius here, right? This is r theta. So to get to this point right here, I would have rotated and then gone out that radius. So this is r1, which means this has to be r2. Everybody understand why that is? Okay. Then I also need this angle that's coming off the pole here. Well, here's what I know. I know to get from the axis all the way here is theta 1. To get from the axis here is theta 2. So how do I figure this out? Subtract them. So it's theta 1 minus theta 2. So now I have the 2 sides and the included angle, because the r's and the thetas are something we would have if we have the ordered pairs. Okay. So to take this and use the law of cosines then, the distance that we are looking for, d squared, is equal to r1 squared plus r2 squared, right? Those are our two side lengths that we have, minus 2 r1 r2 times the cosine of theta 1 minus theta 2. So basically I just took what I have here and substituted it into my law of cosines. Everybody good so far? All right, good deal. So when we come up here, just like when we get the distance formula in the rectangular coordinate plane, we don't care about d squared, we want d. So here is just the distance, and here's the big old square root here, and this is r1 squared plus r2 squared minus 2r1 r2 times the cosine. Now here we wrote theta 1 minus theta 2. The actual formula, if you ever saw it on a formula chart, would most likely say theta 2 minus theta 1. We'll talk about whether or not it matters here in just a second. In the rectangular distance formula, it totally doesn't matter if you subtract backwards because you're about to square it, right? Because if you subtract backwards, all that's going to change is the sign. But when you square it, it doesn't matter. Here, are we squaring anything? We're not. So we'll see if it matters here or not in just a second. Okay, everybody good so far? So the good news now is this is just kind of a plug and chug type of thing. You have the ordered pairs, you have the formula, you substitute it in, and you move on, and it shouldn't be that hard. So let's look at number 10. D equals big old square root. So this would be r1 theta 1, r2 theta 2. So this is going to be 2 squared plus 3 squared minus 2 times 3 times the cosine of, and that's theta 2 minus theta 1, so it's 7 pi fourths minus pi thirds. Even when the numbers are simple, don't do too much of this in your head. I know you know what 2 squared is. I know you know what 3 squared is. This is where the ridiculous mistakes happen when you try and combine things quickly in your head because you think it's easy. Why do I have to write that out? Well, this is writing out the rule. Now, the 100% of this can be done in the calculator now. You don't have to write anything else out. Okay? But does my calculator need to be in degrees or in radians? Radians. Your calculator is most likely in degrees right now. Okay, so let's talk about how to change that. Or if you're not sure because it's so little you can't even read it, because I know that thing's tiny. So once you turn your calculator on, you go to Shift and then the mode key, which is right next to on, and then 4 for radians. So Shift mode is right next to on, and 4 for radians. Okay, so even if it's already in radians and then you do that, it's just kind of assuring you that it's that. And son, the next time you are not getting up and interrupting my class, go get a calculator. It was on the board, it was said yes, and I said it at the beginning of class. All right, so now that it's in radians, you can do 100% of this. Start with the square root sign. Now here, when I write it, I prefer to use parentheses when I write it, so if I'm doing multiplication, I don't get it confused with my bad handwriting with my minus. But in the calculator, you don't have to put all those parentheses. But here's what I want you to do. Hang on, don't get too far ahead. When you go to type these parts in right here, use the fraction key. But I want you to choose one person at your table to type this in the other way, doing pi thirds minus 7 pi fourths. Like a theta 1 minus theta 2. Just one person at your table, type everything in the same, but just reverse those. And then everybody else just type it in like it is. You can do it all in one step. And on these, you absolutely have to close all your parentheses or it will give you an error. Okay? So get it all typed in. Let me know if you're having issues. The pi button is down underneath the scientific notation down at the bottom. Mm-hmm. Mm-hmm. Oh, really? I mean, oh, that's weird. I mean, it's not a major issue, yeah. But I just want to... Oh, I can't. That's strange. And it's even like the same version and everything. Huh. Look at that. Weird. Just make sure you close your parentheses and you're good. Does that make sense? That's, yeah. All right, so what do I put? What's my answer? I know we make a big deal about 3 decimal places, but the truth is sometimes it can come up with something else. It's 3 decimal places unless you are told otherwise. And if you're told otherwise, you have to do what it says, okay? Now, those of you that typed it in backwards, did you get the same thing? Yeah, and we didn't even square anything. No, not on here because it's just straight up distance. But let's think about why it didn't matter. Because if you subtract in the opposite way, some of y'all use negative angles, even though you didn't realize it. So, but we got the same thing. Remember on your chart, it says cosine of negative theta equals what? Cosine theta. So they are the same thing. So even though if you subtract the other way and you get a negative angle, you're going to get the same cosine value because of the way cosine acts. If this was sine, it would be a whole different issue. Okay, we good? Blows your mind, right? All right, I want you to do number 11. I want you to write it down, substitute it in, whole 9 yards. Did anybody have any issues? Let me know if you are, okay? So make sure we agree, do not just write my answer down. Make sure you are typing this in and getting this. And if you are not, let me know. If you get an error, it's most likely a parenthesis issue. And you can scroll back and fix it. You don't have to retype everything. What's error?
I pressed the wrong button.
Oh. I hate that. Okay. You might not, no, you don't necessarily need to start over. You can go back up, go up, up. Oh, there you go. And then, oh, I went up too far. You can go back down. Sorry. Is that what you got? What are you laughing at? You didn't get the right answer? Let me see what you're typing. Give it to me now.
Can I go back down?
But you can go over. That's what you want to do. Oh, go back down to the other. Yeah, I don't know how you do that because you went too far up. Is that what happened? Yeah, I don't know. Yeah. Oh, I probably know why. It might have had something to do with this. You can use the fraction button there. Did you know that? Try and do it again and use the fraction button so that you don't mess anything up on the fractions. You don't have to use the fraction button, but I mean. All right. Anybody else having major issues with this? We got it? We got it? Uh-huh. Yes. Oh, you added these before you squared them. They're squared separately. You don't have it written down right either. Oh. See? You square them separately. That's why. All right, everybody else good? All right, let's move on to number 12. So D equals big old square root. Oh, here's another thing I want to remind you of if you're not getting the right answer and you're not speaking up, that -1 squared and -1 squared are two completely different things. So when you type this stuff in, if you know that you're squaring it and it's negative, I mean, at 1, you can just put 1 anyway, I know that. But let's say it was like, I don't know, -17 squared. Then you could just put 17 squared and leave off the negative so you don't mess something up. Does that make sense? When you're writing it, though, you have to write it the correct way. So even though in my calculator, like this is 8 squared plus, and then this is going to be -2 squared, even though in my calculator I might put 2 squared, or maybe even I put 4, when you substitute it in, you have to substitute the correct numbers in, because if you're getting points for process, this is what you're showing that you're actually doing. Making, doing a couple of different things in the calculator is fine. Then -2 times 8 times a -2 times the cosine of 310 minus a negative 175. And also here, in the calculator, if you want to just go ahead and do 310 plus 175, that's fine. There's absolutely nothing wrong with that. Okay? But what am I going to have to do before I start typing this in? Shift it back into degrees. So change it back. Remember, it was shift mode, then just choose degrees, and then do your thing. Do your thing. Okay, I'll come help you. This is what you should get. I'll put it up there so you can check and see if we know. Error is probably a parenthesis issue, so before you go up too far, let me see. Yeah, okay, that's fine. Oh, look, you put 2 pi 3 over 3. And so I think it probably made it too big, so I can take the... All right, we're getting it. Remember, don't just write this down. Type it in. Let me know if you're having issues. Pearl, did you get it that time? Yeah, okay, good. Good. All right, so if once you agree with me on 12, go ahead and do 13, 100% on your own. This time on 13, somebody asked me about units. You do need units because it is an application problem. Once you agree with me and have the correct answer, then you can go ahead and glue or tape this in. And once everybody's to that point, I want to go over one thing on the homework with you. There's not a mistake or anything. And the homework is one-sided, and that's not a mistake. I know. Let's see. I want you to look at, on the homework. All right, let's look at number 2 on the homework. All right. Because it's asking you to graph 7 pi 12ths, which is not an angle that you know, but it's an angle you should be able to figure out. But since last period everybody freaked out and didn't want to use their brain, let's talk about how to think about this. For this, 7 pi 12ths, if you just think about pi 12ths is how much of pi 6ths? Half, okay? So pi 12ths would be like right here, right? Okay, so when I get to pi halves, if I'm thinking in terms of 12ths, isn't that 6 pi 12ths? Which means 7 pi 12ths is just one more. Make sense? I mean, that's how you want to think about it. And so when you're trying to figure out where it is, this would be 12 pi 12ths, so this would be 11 pi 12ths, this would be 13 pi 12ths, and so forth. Like, think about those, think in terms fractionally, and you can figure out any of them. Okay? And you should be able to do the rest. I'm not going to tell you how to do it all.